Welcome back, everyone. Identify the hybridization of the orbitals that contain the lone pairs in serotonin. When we consider the given structure, there are three atoms that contain lone pairs. One of them is oxygen, followed by nitrogen, and another nitrogen. For simplicity, because there are three of them, we are going to label them as 1, 2, and 3. And we're going to consider those hybridizations. Let's recall that hybridizations can be easily found by identifying the number of electron regions around each atom. So let's begin with number 1, which is oxygen. What we can notice is that oxygen has two bonds. One of them is the oxygen-hydrogen bond, and the other one is the oxygen-carbon bond. So we have two bonds. And we also have two lone pairs on oxygen, because there are 4 electrons, right? So each pair has 2 electrons, so 2 lone pairs. When we add those up, we get electron regions. Let's call it steric number. That's one of the technical terms. Sn, steric number, is equal to 2 plus 2, which is 4. Whenever steric number is equal to 4, the hybridization is sp3. It's quite easy to remember, s1p3, 1 plus 3 equals 4, right? So sp3 is the expected hybridization. However, we have to be very, very careful, because if there's an adjacent pi bond, the heteroatom can have its lone pair delocalized. And this is the case here. Let's notice that oxygen contains a delocalized lone pair due to the presence of the adjacent pi bond within the benzene ring, meaning it actually has an electron pair, one single bond, and one double bond in the resonance form. So the actual steric number is equal to 3. And this is always the case, right? If that atom participates in resonance, well, if it has 3 electron regions, it must be sp2 hybridized. So this is really important. It's not sufficient to count the electron regions and make a conclusion. We always want to make sure that the lone pair actually corresponds to an electron region and it's not delocalized. In this case, it's delocalized due to the conjugation. So number 1 has an sp3 hybridization. Let's focus on number 2. Nitrogen, it has 3 bonds, 2 nitrogen-carbon bonds, and 1 nitrogen-hydrogen bond. So 3 bonds and a lone pair. Which means that the steric number is again 4. 3 plus 1, and the hybridization is sp3, but is it? Well, once again, we have to be very careful, and what we notice is that there are 2 pi bonds, right, adjacent to that lone pair. So definitely we can perform the delocalization of that lone pair, which tells us that nitrogen actually has just 3 bonds, 1 double bond and 2 single bonds. So once again, initially we were incorrect. No, the steric number is equal to 3. And as we know, if steric number is equal to 3, 1 plus 2, sp2. Right? So whenever steric number is equal to 4, that's sp3. If steric number is equal to 3, instead of 4, we get sp2. S1p2, 1 plus 2 gives us 3, right? So once again, we have nitrogen with the same hybridization as before, sp2. As we can see on the screen, there's a mistake. For oxygen, we have sp2. So we want to clearly state sp2. And finally, let's move on to nitrogen labeled with number 3. For nitrogen labeled with number 3, we have 1 lone pair and 3 bonds. 2 nitrogen-hydrogen bonds and 1 nitrogen-carbon bond. So 3 bonds, 1 lone pair. The steric number would be 4, 3 plus 1. The hybridization is sp3. And in this case, we can say that yes, indeed it is, because there's no adjacent pi bond that can be used for the delocalization of that lone pair, right? So in this case, it's sp3. So the final answers are as follows. The oxygen atom from phenol part has hybridization of sp2. Then the nitrogen atom within the 5-membered ring has the hybridization of sp2 as well. And the nitrogen atom from the amine has the hybridization of sp3. And those are the hybridization of the orbitals that contain the lone pairs in serotonin. Thank you for watching.